Wait, one quick disclaimer. If you already know the derivation of the arc length formula, just skip to this part. If not, stay around. Have fun. Okay, so today we want to find the total length of any curve, like almost any curve. Okay, so let's begin. Of course, we first divide up this function into intervals. So let's just define all of these points, x1, x2, and so on. So we have intervals, but x1 is a point, of course. So now we want to look at this line, these lines connecting the function, right? And we want to find out the length of one of these lines first, so that we can later find out the whole function. So what we have here is just a triangle. Over here we have a delta x. We can later substitute this. Here we have a delta y. And then this, of course, by the Pythagorean theorem, this is delta x squared plus delta y squared. So that's the, first of all, this is the length of one of the lines. And now we can like factor out a delta x. So we get delta x, and then the square root of this just becomes 1 because it's squared, right? And then this becomes delta y squared over delta x squared, and we can rewrite this as delta x times the square root of 1 plus delta y over delta x all squared. Okay, so what we need to do now is first of all plug all these numbers in and then sum it. So we have the sum, and let's just say this goes up to x to the n. Sum of k equals 0 up to n of delta x. Delta x is just this part, so we sum up x to the k plus 1 minus xk, and then we get all of the other part, which is the square root of 1 plus and delta x. And delta y is just f of xk plus 1 minus f of xk minus 1. And then we divide this by x of k plus 1 minus x of k plus 1, all of this squared, right? And what you might notice is that this is a sum of infinitely small parts. So we can later just use an integral sign for this. But right now what's important is this part here. And this is exactly just what the equal slopes theorem says. So that just means if we have in an interval, we have any line, this point and this point to connect the line, there has to be at least one point which has the same slope as the average slope, right? So we can substitute this like it's approximately, but approximately is well enough because we deal with limits here. So this is almost f of sum xk, let's just call it squiggly line, and prime, of course. So we square all of this, and because we sum up infinitely many parts, this is the integral. Of 0 we started at 0, so let's just start at 0. And then we go up to some value a. This part, we don't need this anymore, because we sum up all of the parts. And in an integral this isn't important. So we take the square root of 1 plus f prime of x, and then square it, right? Okay, so this is the formula. We're gonna use it to find out some other values right now. But because I'm not the first one to find out this is called the arc length and is denoted as L of, well, we started at 0, so we plug in 0, comma a, comma f of x. So we want to find out L of 0 to A of cosh of x, the hyperbolic cosine, I don't know if I said that. And we get the integral of 0 up to A of the square root of 1 plus cosine hyperbolic prime of x squared. Of course, this is just sinh, and sinh is, that's just equal to the integral of 1 plus, we get e to the x minus e to the negative x, that's just sinh over 2. Then we square all of this, so this is squared. And what we can do now is just multiply all of this out, so we get 0 up to A, the square root of 1 plus e to the 2x minus e to the x times e to the negative x, that's just minus 2, right? 2ab, right? So that's x to the negative 2x, and all of this over 4. So what we can do now is we can write this 1 as a 4 over 4, and then put it all on the same denominator. So this will just be equal to 0 to A of the square root of 4 and 2 cancel, so we get e to the 2x plus 2 plus e to the negative 2x all over 4. And what you might see here is that because of the square root, this is just a this is just e to the x plus e to the negative x all squared, right? But we can also just do it with the 2, so let's just write it like this. Then of course the square root and the 2 here and the squared cancel. And because this is the integral of what you might recall here, that's just sinh, we get back, this is cosh, so the integral of cosh is just sinh. So this is the integral of sinh, and then plug in the values. We use 0 and A here, so this is just sinh of A, because 0 plug in 0 gets you back 0. Okay, so what we can do now is we can take a bracelet, and then because this bottom function is just cosh, cosine hyperbolicus, because of gravity and stuff. I don't know the explanation. Comment if you want to see a video on that. But what we need to check our result is we need a way to say which part of the cosh this is. It might be really steep or really, Okay, so what we want is, that's just a cosh function, starts at 1, right? So what we just take, which is universal, is just this point, which has a slope of 54 degrees, and because the slope just means the derivative, we want to find out this point A, where sinh of A, like the derivative of cosh, is equal to 1. And then we want to plug A into this, but wait, that's just 1, we just said it was 1. So what we get back, not for this, but for the value A, is just equal to 1. That means, because we need to, we need to deal with minus A as well, but this is just the same, so we get equals 2. Don't judge me on the, Okay, so what we do is we take this, and then we try to get it as close to 45 degrees as we can. So this is approximately 45 degrees, and we could count just up the parts that make the change. But we can also just do this and see that this is an equilateral triangle, right? So we know that this is side length of 1, we just defined this, and this is just the side length of 1 plus 1. So we get exactly what we wanted. So if you have a chain with a slope of 45 degrees. You need twice as many material as you need at a length. That's pretty neat. Okay, so let's say you still don't trust me that this formula works. We can just take another one where we know the. Okay, so this is 1 minus x squared. This is just a semicircle, right? So we know that this length is equal to pi. So we can compute that, right? So let's just plug in f of x here and then use the formula. So we get 0, wait, we of course start at -0, -1, up to 1, and we want to find out the arc length. So the formula was square root of 1 plus f of x prime squared. So f of x prime, find out f of x prime. Well, this is equal to square root, so we get 1 over 2 times the square root. The inside stays the same. Now we apply the chain rule. This is minus 2x. The 2's cancel. So this is equal to -x over square root of 1 minus x squared. Now we need to square all of this. So square this, square this, square this, and this is equal to x squared over 1 minus x squared. And now we want to add 1. So if we add 1, this is equal to 1 plus x squared over 1 minus x squared. Now put it all on the same denominator. So this is 1 minus x squared over 1 minus x squared. And now this and that cancel, so we get 1 over 1 minus x squared. And yes, of course, still don't forget the root. We want to take the root of all of this. And exactly. So that's what we need to compute. Right now we do a u sub. Let's say sine of u is equal to x squared, to x, I'm sorry. Now we get dx is equal to cosine of u du. The new integration bounds, they are, well, to get -1 on cosh, that's just -pi. And to get 1 of cosh, that's just 0. And then we plug in sine of u squared. So this is square root of 1 minus cosine u squared. Sorry for the notation. And of course, don't forget cosine of u du. This all becomes 1 minus cosine squared. That's just, sorry. Of course, that's sine squared of u. This becomes cosine squared. So we get 1 over cosine squared. Take the square root. This is cosine. 1 over cosine times cosine. So this is just the integral of 1 du. Of course, we know that this is equal to u. Plug in -pi and 0. So this is 0 minus -pi, which is equal to pi. And that's the result. That's it. I hope you enjoyed. I hope you learned about arc length today. I thought it was very interesting, but I'm not the one to come up with this formula, of course. But anyway, bye.